This is the average rate of change video here. So it's the first problem here, sketch the inverse of the function shown. So what we need to do is pick off some points here. This was some of the slides on the other activity that we just did yesterday. Just to review what to do here. I'm going to pick off some points here. So this point right here is 2, 1. And this point is 3, 2. And 1, 2 for this point. And this point is 4, 5. And this point right here is 0, 5. So I'm going to do the inverse in blue. So I can make a table of values here. So in order to do the inverse, then we're just going to do swap the x and y here. So 1, 2 for that point. This point would be 2, 1, 2, 3. And 5, 0 and 5, 4. And this is going to be a little cluttered here, but let me undo that. So 5, 4. All right, so 1, 2 is this point. 1, 2, 2, 1, same point as that one. 2, 3, right here. And 5, 0, 5, 4. So if I draw a graph through there, whoops. Try to make that a little bit better. Should be a parabola on its side here. All right, so the blue graph is the inverse function there. How can we restrict the domain of the original red graph so the inverse would also be a function? I think we left off with this problem. So one answer could be x is greater than or equal to 2. And if we restrict the domain, that's from here over on the red graph. And the inverse would be this. So in other words, if I restrict the domain, you draw an orange, what that would look like. So that would be this here. If I restricted the domain, it looks like that. And then inverse of 2, 1 is 1, 2. That's that point. Inverse of 3, 2 is 2, 3. So in purple, we can draw the inverse. This. All right. So if I restrict the domain over here on the right, then I get this in purple branch right here, the upper one on the left. So and x is greater than or equal to 2. Then I get the right branch. outlined in orange. The inverse would be the purple. The upper branch of the blue graph. So that's slide 2. So we went over that in some of the classes before the end of class. So this is a review of that slide. And how could we restrict the domain of this graph so the inverse would be a function? So you need to go right here. I don't know if I can plot on here. Let's see. And this point, I can't draw on there, but it's -3, -2. So you can do the x's less than or equal to -3 or greater than equal to -3. One way of representing slope is the change in y over the change in x. And here's the formula: y2 minus y1 divided by x2 minus x1. Slope can be also described as the rate of change. So this graph shows the end of month profits to 2 small businesses over time. Which business is increasing profits faster? So this one, the big cars, is has a steeper slope. Let's see if I can draw on this. I don't think I can. So this slope would be 1 here. So down 2 and over 2. That slope is 1. This slope is down 1 over 2. This slope is 1/2. Let's see if I can draw on here. Nope. So, but the slope of ABC Motors is 1/2, and the slope of big cars is 2. So I can write that in here. The 1/2 and rate of change for big cars is 1. So 2 over 2 or 1. So the rate of change for big cars is larger or steeper. I don't think it's going to let me go unless I submit this. Let's see. There we go. And then slide 6, the temperature of liquid is heated so that it rises steadily over a period of 10 minutes as shown below here, or shown in the graph. What is the rate of change of the temperature? What feature of the graph shows that the rate of change of temperature is constant? So you can pick any points here. So let's pick this one. And this one. So I don't know if I can. So I can do these 2 points here. Let me do parentheses And this point would be 6, this 40, that'd be 50, 55. So 655 is one of the points I'm using. And the other point that I can use there is 445. And then I could do the slope is equal to 55 minus 45 over 6 minus 4. So M is equal to, so if I subtract these two, I get 10 over 2. So M is 5. So it's 5 degrees per minute. So because this is a line, I could just say lines always have a constant rate of change.
For drinking my water.
The graph describes the motion of a computer-controlled train set. The rate of change of distance. The rate of change of distance is not constant. So what is the rate of change of distance over the whole 10 seconds? Remember that the average rate of change is y2 minus y1 over x2 minus x1. So what we can do here is 8, 9. So this is 10 right here, and then 10 100. So at 10 you have 100. And you have the 0.00. So then you have 100 minus 0 over 10 minus 0. I don't know what this says, distance in centimeters, I think it says. So 10 centimeters per second. All these graphs are made of straight lines or line segments, which just tell you about the rate of change. So rate of change is constant for a line or line segment. So the voltage Used in scientific comparison, increases as shown in the graph. Find the average rate of change between A and B. Use the sketch tool to help if necessary. So what you're doing is, if I use the sketch tool, I'm going to use the line segment here. And let me go ahead and make this orange. So if I connect together A and B, I want to find the slope between A and B. And so in the explanation here, A is at 0, 10. And then B is at 3. And let's see what the scale is here. So 2, 4, 6, 8, 10. Yeah, each one of these is 2. So it's at 328. So then you're doing 28 minus 10 over 3 minus 0 is 18 over 3. And then that's 6. 6 volts per second. And then this is the same graph. So let me use purple here. So between B and C now, find the slope of this segment here. So B is at 328, like in the last slide. And then C is at 5.5, 5.5. And the Y value is 38. So good. 38 minus 28 over 5.5 minus 3 equals 10 over 2.5, so 4 volts per second. And then finally, between C and D, So we'll see. Is 5.5 and 38. And D is 8.5. 8.5 and 44. And then we want to subtract the y values again. So 44 minus 38. 8.5 minus 5.5. So 6. 6/3. So 2 volts per second. So you can see that different places on the curve, the rate of change is different when we connect together the line segments here. Which point on the graph do you think the rate at which the voltage is changing is the greatest? So it looks to be C. Or B. It's actually B. So if I so the slope of line tangent to B is the steepest. So if I tangent means it just touches it. So let's see if I can illustrate that. So here's B, and then C looks something like this, and then D is even flatter. So steepest, less steep, and the least steep. Well, maybe I want to change my answer here. Let me look at A here. It's hard to tell. Oops. Let's go with A. That's steeper than that. Okay, the temperature of a chemical reaction is monitored during the period of time. During what period of time is the temperature increasing? So from right about here, 5.5 to a little bit more than 9. So I'm going to call that about 9.2. And then decreasing from 0 to 5.5. Alright, so that's the average rate of change, desmos activity.